Welcome to the Explainer. Today we're going on a bit of a hunt. We're tracking down those massive, bloated container villains that are secretly draining your cloud budget and, let's be honest, slowing your CI/CD pipelines to an absolute crawl. We're going to put your containers on a strict 90% diet. So, if you've ever sat there wondering why on earth your deployments take forever, well, let's dive right in.
Here's the roadmap for today. We'll start with the high cost of bloat, then hit mistake 1, heavy base images. After that, we'll tackle the context trap, single-stage builds, and layer cache kills, before wrapping up with the lean, mean container. We're going to look at exactly how to fix these issues to shrink your images and seriously accelerate those builds.
All right, Section 1, the high cost of bloat. Let's talk about those high stakes and slow builds.
So, Docker was originally designed to be this lightweight, isolated alternative to virtual machines, right? Instead of booting up a clunky guest OS every single time, containers just share the host's kernel. It's brilliant, but if you configure them poorly, you completely ruin that elegant efficiency. You basically end up with something just as slow and heavy as a legacy VM.
And the real-world impact here is pretty stark. Think about it. A 1.4 gigabyte monster container absolutely clogs up your CI/CD pipelines. It inflates your cloud storage bills, and worse, it creates a massive security attack surface just full of unpatched vulnerabilities. On the flip side, a lean container that gives you sub-minute builds, /compute costs, and a tightly secured application. It's night and day.
Let's put a real dollar value on this, just to put it into perspective. If your cloud compute costs, say, 10 cents a minute, saving a mere 5 minutes per build across 1,000 builds a month, that instantly saves you $500 a month in cloud credits. And hey, that's just the compute time. It doesn't even factor in the storage savings or, the value of your developers not sitting around twiddling their thumbs waiting for a progress bar to finish.
Moving on to Section 2, mistake number 1, heavy base images.
So the very first mistake we see all the time is defaulting to generic tags, things like Node.latest or Ubuntu.latest. Doing this pulls in hundreds of megabytes of completely unnecessary development tools, compilers, text editors, the whole shebang. The heroic fix here? Pinning specific minimal distributions. Swapping over to something like Node 20 Alpine or a Google distroless image gives you a fully functional runtime environment in just a few megabytes. It's secure, it's minimal, and it is highly portable.
Seriously, using the latest tag is an absolute liability. Latest isn't actually a version. It literally just means whatever version happened to be built last. If you rely on it, you're practically guaranteeing inconsistent behavior between your dev machine and your production environment. Why? Because that underlying image could change at any second without you even knowing. Always pin your versions.
Okay, Section 3, mistake number 2, the context trap.
You know what happens when you type docker build? Docker bundles up your entire current directory and sends it to the daemon. If you don't filter this process, you end up uploading your entire local workspace. We're talking gigabytes of node_modules or even your whole entire .git commit history. No way, right? The fix is incredibly simple. Weaponize your .docker ignore file. Doing this can instantly drop a bloated 300 megabyte context down to a lean 6 megabytes.
So here's your docker.ignore hit list. Honestly, you need to treat this file exactly like you treat your .gitignore. You absolutely must exclude node_modules, your .git folder, and temporary build directories like bin and obj. And this is absolutely crucial. Never, ever let .env files with sensitive secrets make it into your build context. Keep that context lean, and your builds will start almost instantly. Next up, Section 4, mistake number 3, single-stage builds. To fix the single-stage trap, we bring in multi-stage builds. Really, this is the ultimate optimization maneuver. Instead of relying on one massive container, you split the whole process up. Stage 1 uses that heavy SDK to compile your code. Then, in Stage 2, you start completely fresh with a tiny runtime image, and you copy over only the final compiled artifacts. It's like building a house and remembering to take the scaffolding down when you're done. You leave all the messy construction tools behind. And the hard data absolutely proves the payoff here. Take a look at a standard .NET application. A single-stage SDK image packed full of compilers sits at a massive 827 megabytes. But by implementing multi-stage builds, that final image size gets violently stripped down to just 229 megabytes. That is pure runtime efficiency right there. And hey, it works beautifully for front-end too.
In another real-world example from our sources, a developer applied multi-stage builds to a React application. They slashed the final image size by an incredible 67%. It dropped from a sluggish 1.8 gigabytes down to a highly portable 450 megabytes. Just a massive improvement.
That brings us to Section 5, mistake number 4, layer cache kills.
Now, if we want to unlock insanely fast CI/CD pipelines, we really have to leverage Docker layer caching. Remember, every single line in a Docker file creates a brand new layer. And here's the trick. If one layer changes, every single layer below it gets invalidated and it has to be rebuilt from scratch. Order your lines poorly, and you're just throwing away perfectly good cache.
The absolute most common cache kill happens when you copy all your source code first and then run your npm install. With that kind of setup, fixing a single tiny typo in a README file completely invalidates the cache, which then triggers a massive 5-minute dependency reinstall. It's painful. The fix? Copy only your package.json first, install the dependencies, and then copy your source code. If you do this, Docker will intelligently reuse the previously built dependency layer every single time, unless you actually change a package version. So the golden rule of layer caching is all about strict ordering. You always want to move from the least changed items to the most changed items. Pin your base image first, do your dependency file second, run your install third, and put your highly volatile, constantly changing source code dead last.
And what's the payoff for getting this cache ordering right? How about a 10x build speed increase? By correctly ordering layers and utilizing that Docker cache, real-world benchmarks have shown a Grafana build dropping from 7 minutes to just 20 seconds. A React app went from 14 minutes to 47 seconds. I mean, that is literally transformational for your developer productivity.
Finally, Section 6, the lean, mean container. Let's pull this all together.
All right, here is your high-performance container toolkit to achieve that magical 90% reduction. Pin minimal base images like Alpine or DistroList. Use a ruthlessly strict Docker ignore file. Implement those multi-stage builds. Order your layers properly to maximize your cache hits. And finally, make sure Build Kit is enabled for parallel execution. Eliminate those 4 mistakes we talked about, and your deployments are going to become portable, incredibly secure, and lightning fast.
So, I'll leave you with this thought to mull over. Are you shipping lean, mean containers? Or is your cloud budget secretly funding a 1.4 gigabyte monster? Take a really hard look at your Docker files today. Apply these targeted fixes, rearrange those layers, and honestly, just sit back and watch your build times and your cloud bills plummet. Thanks so much for joining me on this explainer, and